This is a calm, procedural recording. Nothing unexpected will happen. The process will repeat in the same order. How water meter readings are processed. Definition of a water meter. A water meter is a device. The device measures water consumption. Water consumption is measured in cubic meters or gallons. The meter is installed in a water supply line. The water supply line delivers water to a property. Water meters contain mechanical or electronic components. These components register the volume of water passing through the meter. The registration occurs continuously. The meter displays a numerical value. This value represents the total volume of water that has passed through the meter since installation. Water meters are owned by water utility companies in most cases. In some cases, water meters are owned by property owners. The ownership arrangement depends on local regulations. Local regulations vary by jurisdiction. Water meters are subject to regular inspection. Regular inspection ensures accuracy. Accuracy is important for billing purposes. Billing purposes require precise measurement data. Types of water meters. There are several types of water meters. One type is the positive displacement meter. Positive displacement meters measure water volume directly. They contain a chamber. Water fills the chamber. The chamber empties. This process repeats. Each cycle is counted. Another type is the velocity meter. Velocity meters measure the speed of water flow. The speed of water flow is used to calculate volume. Velocity meters include turbine meters. Velocity meters include electromagnetic meters. Velocity meters include ultrasonic meters. Turbine meters contain a rotor. Water flow causes the rotor to spin. The rotation speed corresponds to flow rate. The flow rate is converted to volume. Electromagnetic meters use magnetic fields. Water passing through the magnetic field generates a voltage. The voltage is proportional to flow velocity. The velocity is used to calculate volume. Ultrasonic meters use sound waves. Sound waves travel through water. The time difference between transmitted and received waves indicates flow velocity. Flow velocity is converted to volume. Compound meters combine two measurement mechanisms. One mechanism measures low flow rates. Another mechanism measures high flow rates. The meter switches between mechanisms based on flow conditions. Each type of water meter has specific installation requirements. Installation requirements depend on pipe diameter. Installation requirements depend on expected flow rates. Installation requirements depend on water quality characteristics. Meter reading intervals. Water meters are read at regular intervals. The intervals are determined by utility companies. Most utility companies read meters monthly. Some utility companies read meters bimonthly. Some utility companies read meters quarterly. Monthly reading intervals mean meters are read 12 times per year. Bimonthly reading intervals mean meters are read 6 times per year. Quarterly reading intervals mean meters are read 4 times per year. The reading interval affects billing frequency. Monthly intervals result in monthly bills. Bimonthly intervals result in bimonthly bills. Quarterly intervals result in quarterly bills. Reading schedules are established in advance. Advanced schedules allow for resource planning. Resource planning includes allocation of meter reading personnel. Resource planning includes allocation of equipment. Reading routes are assigned to specific dates. Each route contains a group of meters. The meters in a route are geographically clustered. Geographic clustering improves efficiency. Reading intervals may be adjusted for specific customer classes. Commercial customers may have different intervals than residential customers. Industrial customers may have different intervals than commercial customers. The intervals are specified in service agreements. Some jurisdictions require minimum reading frequencies. Minimum frequencies are established by regulatory agencies. Regulatory agencies oversee utility operations. Utility companies must comply with these requirements. # manual readings. Manual readings are performed by meter readers. Meter readers travel to each meter location. The meter reader locates the meter. The meter may be inside a building. The meter may be outside a building. The meter may be in a meter pit. The meter may be in a basement. The meter reader records the current meter display value. The display value shows total consumption. The meter reader uses a handheld device to record the value. Some meter readers use paper forms to record the value. Handheld devices are electronic units. The units contain a list of meter locations. The list includes customer account numbers. The list includes previous reading values. The meter reader enters the current reading into the device. The meter reader compares the current reading to the previous reading. This comparison identifies obvious errors. An error occurs if the current reading is lower than the previous reading. An error occurs if the consumption appears unusually high. An error occurs if the consumption appears unusually low. The meter reader notes any meter access issues. Access issues include locked gates. Access issues include obstructed meter locations. Access issues include damaged meter covers. These issues are documented in the handheld device or on paper forms. After completing a route, the meter reader returns to the utility office. The handheld device data is transferred to the utility's computer system. Paper forms are manually entered into the computer system. Manual reading requires physical presence at each meter location. Physical presence is time-consuming. Weather conditions affect manual reading efficiency. Terrain conditions affect manual reading efficiency. Manual readings may be estimated when access is not possible. Estimated readings are based on historical consumption patterns. Estimated readings are marked as estimates in the billing system. Actual readings replace estimates during the next reading cycle. ## automated readings. Automated readings use technology to collect meter data remotely. Remote collection eliminates the need for physical visits to each meter. Several technologies enable automated reading. Automated meter reading systems are abbreviated as AMR. AMR systems use radio frequency transmission. The meter contains a radio transmitter. The transmitter broadcasts the current meter reading at regular intervals. A meter reader drives through the service area with a receiver. The receiver collects signals from nearby meters. The receiver stores the reading data. The meter reader does not need to exit the vehicle. The meter reader does not need to access individual meter locations. Advanced metering infrastructure systems are abbreviated as AMI. AMI systems provide two-way communication between meters and the utility. Meters transmit readings to a central system automatically. The central system can send commands to the meters. AMI meters transmit readings multiple times per day. Some AMI meters transmit readings hourly. The transmission occurs through a wireless network. The network uses radio frequencies or cellular technology. Fixed network AMI systems use stationary collectors. Collectors are installed on utility poles or buildings. Collectors receive signals from nearby meters. Collectors forward the data to a central server through internet connections. AMI systems enable interval data collection. Interval data shows consumption in specific time periods. Time periods may be 15-minute intervals. Time periods may be hourly intervals. This data provides detailed consumption information. Automated systems reduce manual labor requirements. Automated systems provide more frequent data. Automated systems can detect certain meter malfunctions. Malfunction detection occurs through analysis of transmission patterns. Data validation. Data validation is a process. The process checks meter reading data for accuracy. Validation occurs after readings are collected. Validation occurs before billing data is prepared. The validation process examines each reading. The reading is compared to the previous reading for the same meter. The difference between readings represents consumption for the billing period. Validation rules check for negative consumption. Negative consumption occurs when the current reading is less than the previous reading. Negative consumption indicates an error. Possible causes include meter replacement. Possible causes include incorrect data entry. Possible causes include meter malfunction. Validation rules check for zero consumption. Zero consumption may be normal for vacant properties. Zero consumption may indicate a stopped meter. Zero consumption may indicate a reading error. Validation rules check for high consumption. High consumption is identified by comparing current consumption to historical averages. Consumption exceeding a specified threshold triggers a flag. The threshold is typically a percentage above the average. Common thresholds are 50% above average. Common thresholds are 100% above average. Validation rules check for low consumption. Low consumption is identified similarly to high consumption. Consumption below a specified threshold triggers a flag. Low consumption may indicate a leak has been repaired. Low consumption may indicate a change in occupancy. Low consumption may indicate a reading error. Flagged readings are reviewed by data validation personnel. Personnel examine the flagged record. Personnel compare the reading to multiple previous readings. Personnel may review consumption patterns over several billing periods. Personnel may initiate a reread for flagged accounts. Rereads verify the meter value. Rereads may be manual or automated depending on meter type. Valid readings proceed to the next processing stage. Invalid readings are corrected. Correction may involve manual data entry of the correct value. Correction may involve scheduling a field visit. Estimated readings are used when readings cannot be obtained or validated. Estimation algorithms use historical consumption data. The algorithm may average consumption from the same billing period in previous years. The algorithm may use the most recent actual reading as a baseline. Billing data preparation. Billing data preparation begins after validation is complete. Preparation converts meter reading data into billing information. The process calculates consumption quantities. The process applies rate structures. Consumption is calculated by subtracting the previous reading from the current reading. The result is the volume of water used during the billing period. Volume is expressed in the measurement units used by the meter. The billing system retrieves the customer's rate classification. Rate classifications include residential. Rate classifications include commercial. Rate classifications include industrial. Rate classifications include institutional. Each classification has an associated rate structure. Rate structures define the price per unit of consumption. Some rate structures use a flat rate. Flat rates charge the same price per unit regardless of consumption volume. Some rate structures use tiered rates. Tiered rates charge different prices for different consumption levels. Tiered rate structures contain multiple blocks. The first block covers consumption up to a specified volume. A first-tier price applies to consumption in the first block. The second block covers consumption above the first block threshold. A second-tier price applies to consumption in the second block. Additional blocks may exist for higher consumption levels. The billing calculation applies the appropriate rate to each consumption block. The charge for each block is calculated separately. The block charges are summed to determine the total consumption charge. Additional charges may apply. These may include base fees. Base fees are fixed charges applied to each account regardless of consumption. These may include service charges. Service charges cover meter maintenance and reading costs. These may include environmental fees. Environmental fees support water resource management programs. The billing system compiles all charges. The compilation produces a total amount due. The amount due is stored in the customer account record. Billing data includes the current meter reading. Billing data includes the previous meter reading. Billing data includes the consumption quantity. Billing data includes itemized charges. Billing data includes the total amount due. Billing data includes the due date for payment. This data is formatted for bill generation. Bill generation produces customer statements. Statements are printed or transmitted electronically. Electronic transmission includes email delivery. Electronic transmission includes customer portal access. Administrative storage preserves meter reading and billing data. Preservation serves multiple purposes. Purposes include regulatory compliance. Purposes include customer service. Purposes include operational analysis. Purposes include dispute resolution. Data is stored in database systems. Database systems organize information in structured formats. The structure allows efficient retrieval. The structure allows efficient updating. Each meter has a record in the database. The meter record contains identifying information. Identifying information includes the meter serial number. Identifying information includes the meter location. Identifying information includes the installation date. Identifying information includes the meter type. Each customer account has a record in the database. The account record links to the meter record. One account may link to multiple meters. One meter typically links to one account. Reading history is stored in the database. Each reading event creates a record. The reading record includes the reading date. The reading record includes the meter value. The reading record includes the reading method. The reading method indicates manual or automated collection. The reading record includes the employee identifier for manual readings. Billing history is stored in the database. Each billing event creates a record. The billing record includes the billing period start date. The billing record includes the billing period end date. The billing record includes the consumption quantity. The billing record includes the charges applied. The billing record includes the total amount billed. Payment history is stored in the database. Each payment creates a record. The payment record includes the payment date. The payment record includes the payment amount. The payment record includes the payment method. Database systems implement backup procedures. Backup procedures copy data to secondary storage locations. Secondary storage locations are physically separate from primary storage. Separation protects against data loss from equipment failure. Separation protects against data loss from physical damage to facilities. Backups are performed on regular schedules. Daily backups are common. Weekly backups are common. Monthly backups are common. The backup schedule is defined in data management policies. Archive data is retained for specified periods. Retention periods are defined by regulations. Regulations vary by jurisdiction. Common retention periods are 5 years. Common retention periods are 7 years. Some jurisdictions require longer retention. Access to stored data is controlled. Access control limits who can view data. Access control limits who can modify data. Access control uses authentication systems. Authentication systems require usernames. Authentication systems require passwords. Some systems use additional authentication factors. User permissions are assigned based on job roles. Meter readers have access to reading data. Billing personnel have access to billing data. Customer service representatives have access to account information. Administrative access is limited to authorized personnel. Data retrieval is performed through query interfaces. Query interfaces allow users to search for specific records. Search criteria include account numbers. Search criteria include meter numbers. Search criteria include date ranges. Search criteria include address information. Retrieved data is displayed in standardized formats. Formats include screen displays. Formats include printed reports. Formats include electronic files. Electronic files may be in spreadsheet format. Electronic files may be in document format. Report generation creates summaries of stored data. Reports may summarize readings by time period. Reports may summarize readings by geographic area. Reports may summarize readings by customer class. Reports may summarize consumption trends. Historical data supports consumption analysis. Analysis identifies patterns in water usage. Patterns inform infrastructure planning. Patterns inform rate design. Patterns inform conservation programs. Data integrity is maintained through validation rules in the database. Rules prevent entry of invalid values. Rules enforce required fields. Rules maintain referential integrity between related records. Database maintenance tasks are performed regularly. Maintenance tasks include index optimization. Index optimization improves query performance. Maintenance tasks include data verification. Data verification confirms stored values match expected formats. Maintenance tasks include storage management. Storage management archives old records to secondary systems. System logs record database operations. Logs document user access events. Logs document data modifications. Logs document system errors. Logs support security monitoring. Logs support troubleshooting. The storage infrastructure requires physical maintenance. Physical maintenance includes server hardware monitoring. Monitoring checks system health indicators. Indicators include temperature levels. Indicators include disk space utilization. Indicators include network connectivity. Storage capacity is monitored continuously. Monitoring tracks the volume of stored data. Monitoring projects' future storage needs. Capacity planning ensures adequate storage is available. Data migration occurs when storage systems are upgraded. Migration transfers data from old systems to new systems. Migration procedures verify data completeness. Verification confirms all records transferred successfully. Testing procedures validate storage system functionality. Testing includes backup restoration tests. Restoration tests confirm backups can be successfully recovered. Testing includes failover tests. Failover tests confirm backup systems activate when primary systems fail. Documentation describes storage procedures. Documentation includes system configuration details. Documentation includes backup schedules. Documentation includes retention policies. Documentation includes access control procedures. Documentation is maintained by database administrators. Administrative storage processes continue regardless of organizational changes. Processes continue regardless of technology changes. The fundamental requirement to maintain accurate records persists over time.